This conference.
Okay, let me get into this. All right, so I fleshed out a bit of the doc. An overview we now have, let me bump up the font size. Okay, so we've got some terms. I'm, I'm trying to be kind of generic and say ownership is control of a device's behavior, and this to distinguish it from I signed the device's identity key, so I'm the owner. Um, like in this doc, ownership is device control and behavior. An owner is someone that wants to authenticate themselves to the device and authorize control. Device behavior, saying a device has at most one owner at any given time. Owners correspond to data center operators, device testing facilities, etc. And I'm making a clear call out here. The device's vendor does retain some control over the device behavior, even potentially like saying, hey, you're only allowed to boot vendor signed code. But that, I'm just making a distinction. That's vendor control. That is not ownership, like in the sake of this doc. Otherwise, devices don't have at most one owner; they have multiple owners. So,
That's good. That's a good distinction.
all right, and then ownership transfers is the process by which the device owner changes and does involve modifying state within the device. Device configuration is, I'm just making term here. This is the keys and other data that control the device behavior, which in and of itself is authenticated by device update key. So this is that layer of indirection we have. I'm just noting this as an entity, but I'm not defining it in this doc, just saying that it exists. And device update key, the key that device uses to authorize updates to persistent device configuration. Device will only honor updates to the device configuration if it is signed by dev update k priv. Device has at most one dev update k at any given time. Control of the private portion constitutes ownership. The manner in which device configuration is signed is outside the scope of the document because device configuration itself is outside the scope of the document. And if a device has no div update kpub within itself at any given time, then I'm arbitrarily saying the device configuration can be updated by anyone. It is in the unowned state. There's a few other options here. We could say it's not updatable at all, or we could say only updatable by the vendor, but I thought this was the more flexible option.
I don't think those other choices work, right? A part coming off the manufacturing line is going to have nothing in it, and you don't want the silicon vendor to be required to update it for different people at that point in time.
So that
I
is
agree.
awesome. Are there any other comments on these definitions so far?
I still don't like the use of the word ownership, but we can go on for now, and I can argue with that. I have some thoughts on ways we could rephrase it so that owner is less ambiguous by using maybe some other terms, but we can maybe discuss that offline.
Yeah, I struggled here to say like owners are a lot of different things. Yeah, if there's other better words, that'd be great. Okay, so I have this section of non-goals for this document. Upfront, countersigning devices attestation identity key is not ownership for the purposes of this document. That can be done by anyone, doesn't require any device privileges, doesn't even require the device's active participation. Now, storing that countersigned certificate onto the device might require device privileges, but that's just like, how do I authorize writes into a device's persistent state? That's a special case of that. So that might be ownership, but that's not specific to this. Cleaning customer secrets from a machine. the same deal. Like, if the act of cleaning secrets requires device privileges, then yes, this involves ownership, but that's just one other thing that ownership would authorize. If it's just a command like, hey, device, clear your secrets, and it just does it for anyone who calls, that has nothing to do with ownership. That being said, a device might want to implicitly blow away any secrets it has upon ownership transfer, and that can be a thing the device manufacturers decide to do. But ownership transfer in and of itself does not relate to clearing secrets.
So Jeff, I'm still stuck on the second sub-bullet of the previous bullet, the act of storing countersigned key certificate. One thing about that certificate, right, is that it basically, if the device is enforcing the fact that it will not allow an update unless it's signed by both parties, whatever, the manufacturer and maybe the owner,
Mm-hmm.
right? Then you need in my opinion, a special privilege that may be different from the regular privilege of just updating any information in that device.
Certainly, yeah.
So yeah, so maybe we need to separate it, right? Because especially if you're trying to protect from like insider threats and that kind of stuff.
Yeah, I want to. Shoot. Okay.
And by the way, maybe the anchor for this stuff is the ownership, right? Whoever is the owner is a very special person within that data center, and that's the only guy that can change things like this type of certificates and things that alter who can update or how the device enforces co-signatures and that kind of stuff.
Mm-hmm. So I was trying to pull up a diagram, but my access is weird right now in my internal state. So to be clear, like if we're pushing updates that are co-signed by like the manufacturer and the owner, that is one thing. That is, and the device would need both keys to authenticate those, right? But I'm trying to draw a very clear distinction between like that is like whether like let's say whether the device takes that update or whether the device boots that code. That is device behavior, right?
Mm-hmm.
This section is purely about the device has an attestation key hierarchy, like a DICE device ID key, alias key, and someone has countersigned one of those keys, saying, "Hey, I'm I'm not going to say owner. I'm the data center operator, and I have possession of this device because I've issued this certificate for its identity key."
Yeah, I mean, I think the question is, who is going to enforce that signature, right?
It would,
Like,
that would
is it
purely be, sorry, go on.
I was going to say, is that, so there's two things, right? Maybe you have an external process where you say, every time I get an update for that device, I have to get through this external choke point, and that's where I'm going to check that the thing is countersigned. In that case, the device doesn't really have to do anything because it never checks the second signature.
Right. Well, this is,
if the device is to check the second signature, now you need to have a secure way of provisioning the necessary credentials for the device to check that signature.
right. Now, to be like, the only entities that will ever be checking this signature, this that I've highlighted here, are things that are outside the device, because the device simply has an identity key, right? It's going to issue some attestation. This is only about the device issuing attestations for other things, like here's the firmware I booted or whatever. That's signed by an alias key, which is signed by a device ID key, which is signed by the manufacturer. The owner, sorry.
It's for outbound activity, not inbound.
Yeah, exactly. The data center operator, let's say the data center operator has some service somewhere which wants to validate these attestations. It's not pushing anything into the device. It's not pushing any code, any configuration changes into the device. It's just querying the device and saying what booted, or tell me about yourself or what you saw. An attestation comes out.
Are you one of my children?
Right. And it wants to know, like, with the certificate that comes with the device, that external, the service, right? It can tell, oh, this statement came from a device manufactured by Acme. But it might also want to know, oh yeah, and Acme, and this device was also ingested into the data center. And it can tell that potentially by checking, okay, is there a certificate issued for this device signed by the data center operator?
Okay, yeah, sorry. Yeah, I think I was confusing that case with the case where you want to countersign updates to the device.
You're right, yeah. So
Okay.
yeah. So
Yeah,
it's all
never mind.
about attestation identity keys here. Okay, so clean customer secrets, and the third one,
So quick question: when you're saying customer secrets, I assume you're explicitly excluding the attestation identity secrets for the device in that statement.
yeah, that's a good point.
Because generally, I would assume the device would rotate its identity at the time of transfer.
I see. I would actually assume otherwise. I would desire the device to be able to issue a statement.
Let me rephrase. The alias certs should change.
Okay.
The persistent device identity obviously doesn't.
Gotcha. Now, let's see. I agree that's a defense in depth. Is that like a hard requirement, or should we make that a hard requirement? Like, the desire there is to make sure that the device is wielding key material that no one else has seen before. So I think, yeah, that makes sense. Let me add a note here.
Yeah, the key word is the trustworthy one, isn't it?
I've not thought of a case where I'd want to keep the alias cert the same.
No, yeah, that makes sense.
So does that mean that we have to introduce device owner into the alias key generation function?
That would imply that, yes.
Yes.
It's already implied, right? You have to. It would be part of whatever you're reading in as your FMC that's feeding into your alias cert generation already.
In other words, well, now, so that I think that would assume that different owners have different FMCs, right?
I mean, you're reading in the ownership and signing keys to validate FMC.
Yes, but does the signature over FMC factor in, or is it just the FMC code itself?
I would have to go back and check
Yeah.
what DICE requires explicitly, if it requires configuration or not.
Right. Are there any concerns from folks on this call about one way or the other on this?
One concern we would have is that not everybody follows DICE. So
Yes.
it's as you have it written, it's okay because that's generic, right? You can still issue trustworthy attestations without following DICE.
Yeah. I think once you don't exclude it or explicitly require it, I think it's fine. Like the solution, it works either way here.
Yeah. Agreed.
Okay. Cool. Now I know there was discussion on a few of our couple of calls, so I do want to spend some time on this one. But I'm calling out maintaining device ownership history as something which can be treated as orthogonal to the act of transferring ownership. You can maintain this history in a couple ways. You can do it internally inside the device state, or with an external database can perform it. I'm just saying, tracking ownership history is not required to fulfill this particular document. So what do people think about this?
Yeah, I think the main issue with tracking ownership history is that it has some requirements in terms of storage. Every time you change ownership, you have to store something and it doesn't go away, right?
Yeah, there's privacy issues. There's
Yeah, there's all
storage.
kinds
There's access. Connectivity issues. It's nice to have, but I don't think it needs to be required.
Okay. And also, oh, sorry.
No, I agree with that. It's probably more hassle than it's worth.
Yep.
Okay, cool. I do note, like in the prior examples of ownership transfer, the device's history does factor into, like, we have this bit saying, can you reverse the ownership transfer, go back to the prior owner? Um, I discussed some changes to how ownership transfer could work, some layers of indirection, which would make that bit unnecessary. So we'll get to that in the doc, but just like the ability to reverse to go back to a prior owner is preserved without the device needing to remember who prior owners were. So yeah, we'll get to that. Okay, so just enumerating here, any other questions on any of these non-goals? Any other non-goals that haven't been mentioned, which probably should be? Okay. Okay, so I'm going to enumerate a few transfer mechanisms. So I do want to, hold on, that's some noise. Sorry. Okay. Physical presence. In this model, so this is saying anyone who can assert that they have physical possession of the device through some kind of interface on the device can directly program div update kpub and the new device configuration. It's useful and doesn't require any coordination between owners when devices physically transfer between entities. And noting that this does not prevent physical adversaries from asserting ownership of the device. This is the trade-off.
Looks good.
From a device perspective, this probably needs to be optional because there are certainly markets and products where that statement cannot be true.
This statement here?
Yeah. Like there are markets where you have to prevent the person physically in possession of the device from transferring ownership in the way that you've defined it here.
Sure. Yes.
You're just enumerating the types of mechanisms, right? You're
I'm
not.
enumerating the types that exist, not mandating that they support them all.
Yeah,
Okay.
that's what I understood too.
All right. Okay, then we describe authenticated ownership transfer. This is the big, this is the fancy one. So in this model, a remote entity asserts control of a private key, and by so doing, programs a new update kpub. This model imposes significant coordination challenges between owners when applied to the devices that traverse the data center supply chain. Just calling this out there. This is a really big problem for devices that go into data centers. But to support authentic ownership transfer, we're going to introduce two new terms. There is a transfer key. It's a key which is used to authorize changes to update kpub. The device can have 0, 1, or several transfer kpub keys at any given time. Control of any one of them constitutes the ability to invoke ownership transfer. And if a device has no transfer kpub, then its div update kpub can be updated by anyone.
So is the this transfer key seems to determine who the owner is of the device, right?
Well, there is a distinction here. Like the owner is whoever controls div update kpub. But that need not necessarily correspond to who controls the transfer keys. For example, and this is how we get into this is how we support reversibility without requiring the device to remember who the prior owner was. So if I'm a device owner, I'm taking ownership of the device, and I want it to go back to the prior owner or anyone, not necessarily the prior owner. Maybe the prior owner is my IT department, but I want it to go back to the vendor, in case, or rather, I want the vendor to be able to assert ownership in case it breaks. Then I can when I take ownership, I can select both my own transfer key so that I can change ownership if I want to, as well as the vendor's transfer key. They both can be resident in the device. Now, this does not give the vendor, the vendor does not control the current dev update key. So they can't just push arbitrary configuration to the device, but they can assert ownership by invoking ownership transfer. And that's a decision the owner can make. Do they want to give the vendor that control or not?
So how many keys does the device have to store of these
So
transfer keys?
we could, practically put a cap on 2 or 3. I mean, I don't know. See a reason why you want more than that?
Oh.
One thing intuitively
No.
I'm stumbling on is if it has no transfer key, then it can be updated by anyone. It's almost the opposite in my head. If it has no transfer key, then it can't be updated by
So
anybody.
this is another kind of just arbitrary decision I had to just put down there. So I put updated by can be updated. It's just like to support the that manufacturing flow. It's going to come out with no, like coming out of manufacturing with no transfer keys. So
Well, if you can assert the dev if the update key without an owner, then you can like I'm kind of having a hard time following here, right? Because if I have a transfer key, then I can change the update key, and if I have the update key, I can change the transfer key. I'm not really seeing how you're separating
the
things here.
control of the update key does not, like, if I control the update key pub, that does not imply I can change any of the transfer keys. The transfer keys are strictly at a layer above the update key in the hierarchy.
But so it looks like is the transfer key like an indirection on the
Yes.
owner key?
Yep.
Meaning the owner key can, within limits, define as many transfer keys as it wants.
No, basically, I can't replace div update kpub or any of the transfer kpubs unless I control one of the transfer kprivs.
Say that again. I mean, I was thinking the transfer key wouldn't allow you to change other transfer keys. Only the owner key should allow you to change the transfer keys.
So basically, okay, so here's a scenario I want to support here. Is I have a device and I want a vendor to be able to take it and assert ownership of it, like complete control of it, because it broke and I want to mail it back without the ability to talk to the device, right?
Mm-hmm.
So that's the scenario. So how do I do that? In other variants of ownership transfer, the way I do that is I take ownership and then I set some bit saying, hey, device, you remember your prior owner, which is the vendor. And also I'm asserting a bit saying you can go back to the prior owner. Like the prior owner has control, the ability to take complete ownership of you. Right. That was I think that was the version that was in that IBM white paper. Is I have this reversibility bit, which the device remembers its prior owner, and I can tell the device you are allowed to go back to that prior owner if they want you to.
And what happens with the secrets for the current owner when you do that? Do they still stay there in the
That
device?
I think that was probably be orthogonal. Like if there's, I mean, I'm not sure what the document said about secrets.
Yeah.
Yeah, I'm trying to figure it out. The simplest thing in my mind for this thing was to say something analogous to what you do in the physical presence, which is saying I have some ability to return this device to some manufacturing defaults. And when it's in that state, anybody can take ownership of it and do whatever. But all the secrets that were in that device before this happened get erased.
So that that basically that devolves into the physical presence transfer option, which I believe someone on this call said is insufficient for certain threat models. Like it's my understanding is like it provides insufficient security to allow anyone to assert physical presence and thereby take ownership of the device in certain scenarios.
Right, but you could do it, you don't have to do it with physical presence, right? You can say the current owner can do that, can put the system in that state, or the device in that state, if
but
it
I think
wants to.
that the purpose of this mechanism is to allow, like, let's say the device breaks, right? Or so if the device, let's say, okay, let's say this is a high security environment. I cannot allow anyone with physical presence to take any arbitrary person with physical presence to take ownership of this device. So it's going to need a cryptographic handshake no matter what, right? In steady state. But I
Okay.
do want to allow, like, if the device breaks and I can no longer talk to the device, I still want the device to be able to be transferred to the vendor. I want to be able to mail the device back to the vendor and let them fix it and take ownership of the device.
So I mean, you're saying the device broke in such a way that the vendor can still access it, but you
Well,
cannot?
I mean, there are scenarios where the device is on, like, a sub-assembly of some board. The device itself is fine, but for some reason, I can't talk to it anymore. Like the NIC is broken, whatever. I'll send the whole thing back to the vendor.
Yeah, I mean, the reason I'm questioning all of that is because the more modes we have, the more difficult it's going to be to get this straight, right? And to do it right.
So,
So we should be very judicious about what modes we actually really, really, really need,
mhm.
right? So if there is the easiest thing in my mind, regardless of physical presence, is to say, I have a device and I have the ability to put it back in manufacturing defaults. And when it put it back in that mode, it erases all the secrets, and then anybody else can take ownership or do whatever they want with it, right?
I agree that's the simplest. In my thinking so far, it's been like, we can't get away with requiring a cryptographic handshake if the customer wants to send it back to the vendor to get fixed.
That, so the question is there a situation? I don't, so the cryptographic handshake you're talking about between the owner and the device, is that the one that you can afford to have?
So in the simplest option, the one that you're proposing, which is
Hmm.
great, it's simple, is the device will not transfer ownership unless it receives a cryptographic handshake between itself and the current owner. Like,
Or if there is some physical presence, you could do, there's multiple mechanisms.
yes, and so that or physical presence thing is what I'm hearing is not kosher. Like, we can't. There are certain scenarios where you cannot abide any kind of physical presence interface to transfer ownership. It has to be pure cryptographic handshake. That's what I'm hearing.
If this is a broken device, okay. So
So I think broken devices follow a different flow, right? RMA, you would typically have, I want to separate ownership from state as well, like device state, whether something's production worthy or something's been recycled or returned to manufacturing. The typical model for that is devices before they're shipped out after ATE and packaging, before they're shipped out to the world, they're put into a production state. And then when they're end of life and brought back to manufacturing, whether due to premature failure or not, they're put into a non-production state, and they cannot transfer from a they can transfer from a production state to a non-production state, but they can never go back to a production state.
So that's a nice, like, I wish it all worked like that, but we're seeing flows
That's
that are
difficult, right?
circular,
It,
where, like, a device will, like, let's say there's a sub-assembly with several devices on it, and the vendor delivered the sub-assembly and all the devices all in one component, something on the subassembly has broken to the point where we need to RMA that subassembly. But the devices themselves are functional and will come back to us in a different subassembly.
And I'm not seeing the correlation. So they'll remove those devices from a subassembly, and they'll put them on another subassembly because they're not defective, and they'll send them back out. So your challenge is what in that flow?
The challenge is, like, let's say those devices are owned by me, but something on the subassembly broke, so I can't, like, I have a broken subassembly. I'd like to mail it back to the vendor, but I can't contact these devices to de-own them or put them back in any kind of manufacturing state. They're still owned by me. So by the time the subassembly reaches the vendor, they've got a bunch of devices that they can't control because they're not me.
See, I thought we went through the options on not requiring that the ownership is pre-unowned before shipping it out of your data center, and there was options for having your ownership key or unownership key, I guess, delivered along with that device to relinquish control of it.
So there is that option, and if we, yes, you're right. If we decide that, like, you can that we can have this, that requires some coordination. It requires you to, like, and I described this later in this flow.
Okay.
If that flow is sufficient for the RMA case, then we could drop this transfer key layer of indirection. So let me take a note of this.
But do you see a problem when you return a subsystem back to your vendor, and when you transfer ownership of the chip to your vendor, the vendor have access to all the OTP content of the device. And if some in the OTP, it contains some of your secret, do you care if you allow the vendor to be able to read all those content?
So this gets into to what relation does secret sealing relate to ownership transfer? So I feel like there are two answers there. One, it would be nice if the device should ideally have some kind of some way to program entropy into it, like rotate entropy, so I can just destroy the chip's ability to unseal secrets, and that can be orthogonal to ownership transfer. In the case where the device breaks, I can't issue that command anymore, so it would be nice to have some kind of implicit, hey, ownership transferred, secrets are destroyed behavior. And I did call that out up here. A device that holds on to customer secrets may choose to implicitly wipe them upon ownership transfer. I think that angle would address your concerns.
Okay, but if I do that, that means that chip is not going to be able to be reused and put it on a new subsystem and return back to you anymore.
It depends on the lifespan of those secrets. If the device is no good anymore because it doesn't have any of those secrets, then yeah, it would be end of life. But if you can reprovision the secrets anew, so some new sealing key, that would probably be okay. I think.
Because some of the secrets in the OTP, right? OTP size is limited.
So you can do a layer of indirection there and, like, seal some large amount of secrets to some small amount of entropy in the OTP, ideally. But that maybe you can't afford. Maybe there's nowhere else to store the secrets except in fuses, so that is a challenge.
Okay.
And Jeff, I would agree with you that keeping the wiping of secrets, it's a related activity, but it's not necessarily the default. It should be separate.
Because not all devices will store secrets of any kind.
Exactly.
So, Jeff, I guess an observation then is your thought is if I put the transfer keys in, I don't have to worry about coordinating between the RMA return, a functional device, or some signed piece of data going back with the device to the original manufacturer.
That's correct. There are two ways of solving this RMA flow. Either I, ahead of time, give the vendor authority to assert ownership through one of these transfer keys, or I have to go out of band and send some signed payload to the vendor when I actually RMA the device.
And then as the owner of the device, you would install the transfer key,
Yes.
pre-provision the transfer key upon bringing it into your data center,
Mm-hmm.
with the idea that I control when this could happen because I decided to put this key in there.
Exactly. Similar to how in other versions of ownership transfer, I decided to flip that reversibility bit on. This is just a different version of that. I decided to put the vendor's key in here.
Okay.
Jeff, I had a question on the transfer key. Uh, in case of multiple transfer key, I'm assuming when the device ownership transfers from X to Y, and then if Y wants to do to Z, so the assumption is the transfer keys physically needs to be, kind of transferred over to the next set of ownership so that the flow can continue.
Well, that's
Um,
actually described
uh,
down here. Let me let
okay.
me address this, and then I'll see if that answers your question. Before I get there, though, I want to mention now in slide decks we call this a nonce, but then we said, hey, let's make it long-lived. So nonce is kind of weird. So I called it an owner epoch here. A statistically random non-secret value reported by the device, which changes only upon ownership transfer. You may store it within the device's raw entropy, or you could derive it based on a KDF of the serial number and some monotonic counter. Other implementations are possible. But this is the thing that provides anti-replay for signed ownership transfer payloads. The way this is all used is here. So when you want to actually do an ownership transfer operation, so you provide a new div update kpub, a completely new set of transfer kpub keys. So you are completely replacing all the transfer keys within the device. New device configuration signed by div update k, the device's current owner epoch, and a signature over all of these values generated by one of the transfer k priv keys whose public portions are currently programmed into the device. So the device will make sure the owner epoch matches, that the signature is valid based on one of its current transfer keys, and then replace all of these with it will place these inside the device instead of its current values, and then it will rev the owner epoch.
And you're deliberately not choosing to have dev update key authorize this. It's got to be a transfer key.
That was a layer of indirection because like when I take ownership of the device, there's only one dev update k, it's mine. But I do want the vendor, or this is the design here was to allow the vendor to assert control of a transfer key, but not necessarily a dev update key.
Yeah. So even if you're the only one who deals with this, you still have to put a transfer key in.
Yeah. Now, like, we could flatten this if we wanted to. Like, and again, assuming we keep transfer keys, because that's an unresolved question. But if we keep transfer keys, we could flatten this anyways and say, hey, a device can actually have multiple div update k pubs, and any one of them can be used to authenticate like a device configuration. But I thought that was a little bit less nice because then you like it places the data center operator and the vendor on co-equal footing. They both have equal say over the device because they both control a dev update key, which can both authenticate device configurations. So
Yeah, that's reasonable. It's like key hygiene.
yeah.
Key transfer is the only one that does the changes the update key.
Exactly.
It's all right.
Any other thoughts on this?
So Jeff, is this more of a recommended flow, or this is the way we want to see these things work? That's one question. And the second question is with respect to like enforcement of anti-rollback or key revocation, things like that. So which keys do you envision using for that purpose?
You're referring to, let's say I want to rotate my dev update kpub because it's too old or leaked.
Yes, yeah, let's say that. Yeah. Or I want to just revoke something that was already out on the field.
Yeah, so I feel like a revocation of a dev update kpub could simply be let's do an ownership transfer for my devices and have a new dev update kpub sent out. I need not necessarily change any of my transfer kpubs at that time.
Okay.
I can program the same set out as I always have because maybe those didn't leak, or maybe I want to change the whole thing because all my keys are too old.
Okay. So, and this is coming back to the first question. So this is more of a suggested implementation, or this is how we want to see it? Because there might be implementations where we want to keep the transfers key in OTP and and field programming, though the OTP is not something that is kind of encouraged.
Yeah.
So and also the limited number of space and everything. So basically, I'm getting at a model where um, you have different set of transfer keys programmed on the device, and you perform the device ownership transfer more based on revoking the transfer key and then physically transferring those keys to the next owner. Is those things also something that we thought about, just considering the memory constraints over the devices? Just curious on if this is going to be the suggested model or if this is the model. Yeah.
That's an interesting angle. I hadn't really like um, in designing this, I thought either the device has internal flash and we have plenty of space to write. Although as noted in a comment that's still captured here somewhere, um, Flash does have endurance limits, so we can't assume that Flash can just be written as many times as we want. So that is something to keep in mind. But yes, and then if a device only has internal fuses, let me scroll back up. You could still, I mean, do some kind of RPMB mechanism to be able to store lots of data. Well, I guess you wouldn't store lots of data, but you could like authenticate lots of data and have anti-rollback there. You would need to store those bits somewhere else, though. It's like you could imagine that all this data, the dev update kpub, transfer kpubs, configuration data, that all is stored, in some flash chip next to the device, and then it's HMAC'd with some kind of monotonic counter stored within the device, and then that kind of collapses your space constraints. But that might not always be feasible. Maybe you don't have a flash chip next to you that you can use.
Yeah,
So
so yeah, that kind of goes back to the question, which is the flow you're suggesting here. Is it like a suggested flow, or is it like this is how it needs to be done kind of
well,
thing?
I think at this stage this is a suggestion, but I think the desire is to mature it into something which is something we all agree we can
Okay,
settle on.
got it.
So that I'm gonna put a note somewhere.
And another kind of fundamental question I had is in this whole device transfer of ownership, are we okay with some of the the transfer keys transferring the keys physically to the next set of owners, or we want to have the ability where the key exchange itself does not need any you know um, responsibility as such. It's all like all keys are always updatable. So that's another question I had.
So your question is whether we can tolerate any of these keys being fixed for the lifetime of the device?
Yeah, like one thing is, let's say you have a number of transfer keys, and every time you transfer, you physically give the transfer key so that if you wanna transfer it to somebody else at the later point, you can use them, sort of thing.
That sounds like it could work.
Yeah.
I need to be fleshed out though.
Okay.
We could chat sometime
Got
to
it.
completely understand the needs there.
Is the
Sure.
transfer key unique per device or just a single transfer key for all the devices?
That would be the owner's job to settle on that. I would imagine they would very likely pick one common key that all the devices share. But
Okay.
you could theoretically partition your fleet, say, these devices honor this transfer key, those honor that one. You could do that.
Okay, thank you.
So why do you need to have several transfer keys?
You would,
If
I
you
mean,
want to transfer the device to the specific location, to the specific owner, why you need to provision multiple? In general, you have to authorize only one transfer, right?
yeah. I mean, I'm imagining, different trust boundaries, right? Maybe like some devices are in some high security area and we want to store their transfer keys, in some kind of offline HSM, because we can tolerate that pain. The security trap is worth it. Maybe other devices are in a less high value environment and we can store their transfer keys online, just as a hypothetical scenario.
But in this case, you have a possibility what the transfer may happen, like the ownership may be picked up by the owner which shouldn't pick it up. Like if you have multiple keys, it
Oh,
means
sure.
it's
Yeah, I mean, oh, sorry. I think I'm hearing two different versions of multiple keys. So like a device can have multiple transfer keys at once. I think that's true. But like, I think the question was, could you have multiple like each device? Let's say each device has one transfer key, but there are multiple transfer keys in circulation because you're assigning different transfer keys to different devices in your fleet. Like, is that the question
well, as I understand, you have to use the transfer key only in the case when you want to ship the system to the different owner or to the RMA, right? So you
Yeah,
as the
you're right.
owner will generate the transfer key specifically for that purpose. So
Yes.
and like my question was, if you want to do it at the specific time for the specific reason, in this case, you need only one transfer key for that reason.
Yes. Like you as the owner, when you program a second transfer key that belongs to someone else, like the vendor, you're kind of putting the device's fate in their hands in a bit. You have to trust that the vendor has good key hygiene there. Otherwise, don't program the vendor's transfer key into your device, and then you have the burden of de-owning the device before you send it there.
Okay. Okay, thanks.
Yeah.
So, Jeff, would it be possible to have maybe the document should have this a diagram where we have the keys, right? There's one owner key. That owner key can be used to generate multiple transfer keys, and any of the transfer keys can be used to generate or change the dev update key, correct?
So that's true, except that there is no owner key.
Okay, so this is probably what we need to, it'd be good to figure it out, right? What you can do, so we know what you can do if you have a transfer key, right? Is change the update. Are there any other things that the owner can do beyond that? And if there are, does the device need to enforce security on those, which means you would need another key?
Yeah. So yeah, I'll put that in diagram or flesh it out. Just to answer your question, transfer keys are single purpose. They only authorize a new set of this stuff. Dev update keys are single purpose. They only authorize a new device configuration. Device configuration is multi-purpose. That's where we get into whatever the device wants to do. Like if the device will only boot, vendor signed code, then you can put the vendor's public key in the device configuration. Or flip that around. If the device will only boot owner code, then you can put the owner keys in the device configuration. And if you ever want to change that configuration, you can authenticate it with a dev update kpub.
So, okay, so you're basically, are you saying if you have a transfer key, you're more or less the owner, or not more or less, you are the owner, and you can do anything the owner can do?
There's a subtle distinction. You can make yourself the owner if you have a transfer kpub, which that's you kind of squint in it. It is subtly different, but you can give yourself all the privileges of an owner. You don't have them yet, but you can grant yourself them.
So how does the device enforce all the privileges of an owner? It's just this list of things here that the owner can do.
So the device configuration will have a list of all the things the device can do, like what code it can boot, who's allowed to, what pins are on, JTAG enabled, whatever. That's in device configuration. If you want to change any of that stuff by exerting control of the device, you sign a device configuration with a dev update kpub. That's ownership, is control of a dev update k.
So Jeff, when you say you're going to put a diagram in, are you going to put like a state transition diagram that might?
Yeah.
Is that what you were thinking?
I was thinking like a key hierarchy, but that's a good idea.
I mean, I think if you put that in, it would, and maybe do 2 layers of RMA.
Oh yeah.
Like you own it. It goes back to company Z. They look at it for a while. They send it back to the chip guy because it could look that way.
Right. The other thing that is not mentioned here is we were saying that we want to separate the clearing of the secrets from the ownership transfer. But the question is, who can do the clearing of the secrets in the device? Right? Is that the owner?
I should think yes. An owner should be able to clear secrets, and that could either be, for example, let's consider the case of a TPM. Like in certain cases, anyone can call TPM clear, or it could be lockdown, whatever. But like, actually, that's getting a whole world. So that's different. Let's just imagine there's a command which says, hey, clear secrets, and anyone can call it. In that world, clearing secrets is completely orthogonal to ownership transfer because anyone can clear secrets at any time. But maybe you want the device to autonomously clear its secrets when it transfers ownership, and that is the intersection point, I think.
Yeah, or also you may not want somebody to just come and clear the secrets of the device without you wanting.
Yes, that's the other way. Yeah,
right?
so maybe you don't want a wide open clear secrets. So that would be
right.
Some key inside the device configuration will say who's allowed to call this command.
So maybe it would be a good exercise to say, what's an owner? What can he do? Right, and have a list of all of those things. I think some of the things in your previous list of bullets describe some of that, right? But things specific to secrets and other things, right? And are all of those things controlled by the device update key, which I think is what you're saying, right?
Yep.
Yeah, and I was thinking that one of those things is whether or not secrets should be cleared on a transfer. That the device owner makes that decision and sets something in there that says, when you do an ownership transfer, wipe it or not. Maybe I'm simplifying it too much. Sort of a level of indirectness.
So Jeff and Elaine, in the device, in the key hierarchy, I'm assuming the device ownership key and the PCA, all of that, all the key set that we have listed in the attestation, so they will also be kind of included.
Let's see. They may. I was trying. So I like to keep the attestation hierarchy very orthogonal, except this one note where alias keys may want to change on ownership transfer. So yes. Let's see.
I'm trying to kind of differentiate between the transfer key, device update key, and the device owner key. Transfer key, device update key kind of makes sense. I'm trying to define a need for the device owner key in addition to the device identity key and the device attestation key.
Yeah. Now, so that.
Yeah.
Can you like clarify what you mean by device owner key? Because like owner key has been used a couple of times and it's kind of ambiguous at this point. Are you referring to the key which endorses a device's identity?
Yeah, exactly. Yeah, device owner CA. Yeah, exactly, correct.
That's
Anybody
the
can create that. You can even create that offline. The device gives you its public key. You can go and create your own certificate from that using a null sign CSR and go sign it. That really does nothing for ownership.
Yeah, so that's correct, Brian. I just want that to kind of fit into the ecosystem, because when you do the transfer key, then my assumption is you have to go and kind of flush out your certificate chain with the new device owner CA as well. Right?
Not really.
Yeah.
No.
you don't have to.
Yeah.
I mean, you don't have to, but just by the term that it's the device owner CA, my census is okay.
We should
If I
probably.
did, yeah.
Yeah. I mean,
yeah.
I get the confusion, and I think like we address that by like saying there's no such thing as an owner CA, because owner is not about identity.
Yeah, just because this is all talking about ownership, and that's the ownership CA. So I'm just saying, if you can kind of look at that nice table that Elaine has for all the keys and the use cases, in addition to the state diagram that you're going to add, maybe you can kind of clarify some of the things there are here when people read these two documents together.
That's a really good catch there, because if we're talking ownership in terms of the definition Jeff has, the very good definition Jeff has, then you would imply that it also affects this owner key, let's call it the owner certificate over that device, that would probably change.
Yeah, because if that changes, then if you look at it from SPDM perspective, then your certificate chain changes, which is kind of basis for before you mine the attestation measurements and things like that.
Yeah, because you're saying in the original case, this device is in my fleet, for example. I have deployed it in my fleet. It's one of my babies here. And then when you transfer ownership, it's no longer in your fleet anymore, right? It's off on a truck somewhere or wherever it went. And so, and what do you do with that?
Yeah, I mean, it is kind of obvious that you would provision a new set of certificate chain, but I just want it to be called out so that you don't leave that set of the device infrastructure as is, but you do this backend kind of confused.
Yeah, and do we have to revoke it or something?
Yeah, you would revoke it offline. You don't need the device for that. What if the device got stolen before you got to revoke it? You would do the revocation offline.
Yeah, so that's an important thing to put in this document too, which is don't forget to revoke your ownership certificate, I guess, if you do this.
One question about the device update key. So the device update key has to be verified during the probably boot time or update time. Who will authorize it? Who will sign it? I kind of assume it should be authorized by the owner, by the system owner, but looks like you. So I kind of assumed what when you do transfer, you use your transfer key to instantiate new owner key in the system, and this new owner will authorize the device update key. Is that a wrong assumption?
That's not quite. So I actually as I don't have owner key as a thing in this document. So the div update k is kind of self-evident. It is essentially the root of authority when it comes to like what updates the device will allow for its configuration. Like any so when the device boots up, it'll have a div update k pub within itself, and it will just take. It does not require that key once it's in the device to be endorsed by any other entity. And this div update can be used to authenticate changes to device configuration.
But in this case, you have the situation when if there is an attack on the system, anyone can provision the device update key, and it can be anything because it's not authorized on the system at any point of time. It can, anyone can install any updates on the system if there is the security issue and this key is not protected well.
That's true. That's true. I don't think adding another key in the hierarchy will fix that problem, though.
Well, unless one of your keys provisioned into the OCP and you maintain the chain of the keys and the history, where you can verify from immutable point to the last key.
So what you're proposing, I think, is another thought. Is the same thought that was shared earlier. Is that, there's some notion of ownership which is persistent in the device. OTP does not change, and so I can't just wholesale replace the update k because it's fused in the device. Although I could potentially rotate it by signing one key with another key directly.
Right. If you will maintain the history of the certificates and the keys, you have way to validate every key what was provisioned into the system. So you can maintain the chain of the keys and keep the security. Like you may in general detect what somebody tried to modify your keys and modifying the chain of the keys.
Does this capture the thought?
Well, this is going back to the ownership discussion. If you make the transfer key is immutable, you assume that's your like a initial ownership key, right? And you will use it to as the entry point to verify the other keys in the chain.
Mm-hmm. Okay.
Yeah, I kind of thought that the immutable, it should be like it's an owner key. So the first one can be OEM or DM key, which is provisioned into the system initially. But
okay, because yeah, I think like the authenticator ownership transfer is like using one key to endorse another key, but doing it in a replay protected manner because you have that owner epoch going on. But I think what you're proposing is a kind of a different flow where you have some immutable key in OTP, and that key will endorse the next key, which will endorse the next key, and so on.
Right. So when you do like a transfer key, you're allowed to create this. In general, if you want to provision next key into the system, you have to get the signature from your previous owner.
Yeah, and that's basically that is what transfer key provides.
Okay. Yeah, as far as it goes from the immutable key, I think it will be better protection for the system, so no one can provision the random keys.
So basically, what I think that flow can be satisfied by having like the device's initial transfer keys be an OTP, and then you can put new transfer keys in there if they're authenticated by the prior ones, but then the new transfer keys have authority, and so on and so on.
Right.
Which basically is this flow, but just putting transfer keys in ROM instead of leaving it wide open at initial manufacturing.
You'll put an initial transfer
You
key,
put it
but
in pieces, yeah.
The transfer key can be changed, but your initial transfer key will be in the TPM.
But then what authority does the initial transfer key have once I've transferred to a new one?
Question.
So the previous, if you want to transfer to the new owner, the current owner will generate the transfer key and provision into the system and provide the new owner of the second part of the key so he can provision its own device update key and probably ownership key or
Yeah, I think that flow is what's captured here, I feel like. Like the old transfer key priv endorses the new key set.
Yeah, the only thing, the transfer key will be generated by the current owner before it will transfer to the new owner. But as I'm new owner, I want to create my keys. So I want to remove this transfer key and provision my own key and authorize device update key as well on that system.
So if I'm trying to understand, the question is whether that set of keys, any one of which will work, or if it's a series of transfer keys, only one at a time being authorized. Is that the question? I think, Danielle, you're saying you want the series. Whenever there's a transfer key, it replaces the old one, and there's only one at a time.
Yes, that's right. And as I understand, the transfer key, it belongs to the previous owner because previous owner generates the transfer key. But the new owner of the system may not want to use the transfer key as the authorization key and want to provision its own key to authorize, for example, device update key.
So if I have a device and I'm sending it to you, I know I'm sending it to you, which isn't always the case in data centers and whatever, but let's say I will ask you for your transfer key. And then once I have it, I will issue one of these signed blobs and have your transfer key here, your div update kpub, your device configuration. I'll sign it with my transfer kpriv, which is currently in the device. And then I'll apply this, and as a result, the device will now become owned by you. It will have your transfer kpub, your device update kpub.
Oh, okay. So it's like the other way. So I have to, as the new owner, I have to send everything from myself to you, and you will sign it and give it me back. But do you see the situation when you, as a current owner, you want to generate this information and provision your transfer key and send as the package to the new owner, so new owner can do whatever he wants to do.
So I can do that. So the way we've defined this is if the device has no transfer kpub, then its div update kpub can be updated by anyone. So I could theoretically, do this to myself and have, instead of your keys here, just have empty, like no div kpub, no transfer kpub, some generic device configuration. I do that to my device, and then when you get it, you can program whatever keys you want in.
Oh, okay. So in general, in this case, device will be opened.
Right. That's the trade-off. Do I want the device to be open for anyone in transit, or do I want to lock it down so it's only for you? So in transit, no one can touch the device. That's a knob I can decide to change.
Okay.
Yeah, and there's a variation on that where the transfer key, if I'm transferring a bunch of devices to Daniil, I can put in a transfer key that only he knows, but that's not his final production key. Like when he gets it, he's got to go rotate it one more time to put in the real one. that the
Right.
transfer keys are just transfer.
I could
Yeah,
also hypothetically. Oh, sorry, go on.
yeah. If you ship the like a multiple servers, multiple system to the owners, you may don't want to request any information from this owner if it's like a lot of servers. You want to ship it, but you still make sure you protect the system from the unauthorized ownership change. So in general, you provision your transfer key into the system and ship the systems, like 1,000 systems, and then you will transfer the other part of the transfer key to the new owners via like a secure channels. So in this case, you don't care about the other people keys and stuff. You just generate it in the factory and you ship it like.
Yeah, I think there's like 3 ways I could do this. I could know your actual transfer key already and just pre-program that. I could program no transfer key so it's wide open, or I can make one up, a transfer key, and then send it to you in a secure channel.
Right.
So, but the device, as far as the device is concerned, is the same interface.
Yeah. Yes.
There is a little bit more to this document. I know we're quite over time, so I don't want to like get into it, but kind of describing the coordination challenges involved in authenticated ownership transfer. So, but
We can keep going next week.
Yeah. Yeah. Next week will work. Yeah.
All right, I'll just get you back on the agenda for next week then.
Cool.
Thanks, Jeff.
Thank you all for the comments.
Yeah, thanks, Jeff. Thanks for drafting this.
You bet. You bet. You bet.
Right. Bye-bye.
All right, thanks everyone. Have a good week.
You too.